Good afternoon, fellow Plexers. Today's video is going out to both Cameron and Eduardo because both had recent questions about transcoding under Plex. So just to point out, Plex always has great support articles. This is a very short one on the topic of transcoding, and this is a longer one on the topic of hardware accelerated transcoding, which is a Plex Pass feature, and there's official support for Intel iGPU's, which is basically a GPU bolted on to the CPU. It's not really bolted on, it's part of the whole die process, but it allows video out, and the CPU is providing that video out, or a regular Nvidia video card. So you want a modern version of each to have hardware accelerated transcoding, and different Nvidia cards can do a different number of transcodes, just like a latest generation Intel iGPU can do more transcodes than an older one. An HEVC encoding or transcoding is going to be available on 7th gen or newer Intel processors. Then we have the added Intel rub where an F model processor does not have an iGPU built into the CPU. So I'm not going to read through this article. That's basically how it covers it. What I'm going to do is show you some transcoding examples. I have multiple servers running right now. So let me explain them. This Unraid 63-2 server is my old regular Plex server hardware that I just swapped away from. It's an Intel NUC running Unraid pointed back to my newer Synology NAS where the media is, and it has a fabulous Iris Xe Tiger Lake family iGPU that's part of the mobile 11th gen i5 processor in that. Now, here's a little secret. The 11th gen desktop processors, or any generation of a desktop processor, is probably one step behind the mobile version from the same generation. So whatever family the desktop 11th gen processors are, it's not as new as the Tiger Lake family from the mobile version. So if Plex has a barrier to cross where they've done an upgrade to the iGPU, you'll see that new upgrade in the mobile version first before the desktop. So basically 7th through the 10th gen, maybe the 11th gen desktop processors are going to be similar performance. So most of the 8th through 10th gen desktop processors have the UHD Graphics 630 iGPU in them. The mobile processors will have an Iris Xe iGPU, or it just might be a UHD Graphics one for the newer ones. So we'll go through this, and what I want to do is I want to click into each server and go to the transcoder settings. So this is my old hardware that ran Plex up until 3 weeks ago. And I always drop down here and change from auto to the actual iGPU and hit changes just so you can see it easier. You see this has the ability to use hardware acceleration when available, to use hardware accelerated video encoding, to use the new experimental enable HEVC video encoding, and enable HEVC optimization. This is also the borderline where you can have tone mapping under Windows. It has to be, I believe, Tiger Lake or newer. So an 11th gen desktop processor won't have HDR to SDR tone mapping during a transcode under Windows, but the mobile version and above, like the 12th gen desktop version, will. But this new feature kind of eliminates the HDR to SDR tone mapping during a transcode. which is great for everybody. So if I change to the snap package of an Ubuntu Plex server running on this 12th gen i9 processor of my desktop PC, you'll see I've got an Nvidia GeForce RTX 3060 GPU in this test Plex server. Now here's my normal server, and I just slid new hardware under my Unraid install. It's a 14th gen Asus NUC with a Meteor Lake iGPU, and unfortunately the Linux kernel that is running under Unraid 7 does not see my iGPU, so I don't have it. Well, I can show you what transcoding a 4K video is like with this server because there's no iGPU. So everything will be raw horsepower of the CPU. Now, if I threw an Ubuntu test drive with a test server in that hardware, Ubuntu's Linux kernel is newer, where I then have the iGPU to activate. Going down the list, this is my older Synology NAS where I first ran Plex on. And that has an Intel HD Graphics 500, which is similar to the iGPU in the 7th gen desktop Intel processors. Only this one does not have the HEVC capabilities that a desktop 7th gen processor would have. And don't quote me, that iGPU is either the Intel HD Graphics 530 or 520. I don't remember the exact name, but most of the desktop 7th gen processors will have the HEVC capability. And then lastly, my newer NAS that still has my Plex media on it and has the full trash guide setup in Docker containers running. This has the UHD Graphics 600, which is very much on par with the common UHD Graphics 630 iGPU that you'll find in most but not all of the 8th gen through 10th gen Intel desktop processors. Now, Plex doesn't have official support for an iGPU or a GPU from AMD, but you will find some of them work, and you may see them down here. But there's no way to quantify how powerful it will be, where you can kind of see, depending on the Intel iGPU or the Nvidia GPU, how fast it'll be. I'm not going to look for it now, but I'll try to remember to put a link in the description for a URL that charts out all the capabilities of different Nvidia GPUs. My 3060 GPU in this desktop computer is supposed to be able to do 10 high bitrate 4K HEVC streams transcoded down to 720p 4 megabits per second before having an issue. Well, that's about the same as the iGPU in this 11th gen Intel mobile i5 processor. They're pretty much capable with each other. So off screen on my second monitor, I have the HTPC client app set up, and I've pinned all these different 4K libraries and then turned down the volume on this. So I'll be going through it just in this order. My current server, which no longer has hardware accelerated transcoding, and I will be using the same 4K test media file. Where is it? This has a bit rate of 104 megabits per second for a direct stream, and we'll transcode that down to 720p and see how it affects the CPU usage in Plex dashboard for each of the different iGPUs or the GPUs or on the CPU of this actual system. So this is where we'll start. So I'll bring this off screen. And again, I'm just going to run down Well, I should start in this order. So let's start with my old hardware. So I'll get set up for that off screen. Okay, so I've started the stream, so let's click into dashboard. All right, you'll see that it's 104 megabits per second. It's a direct stream. It's a 4K Dolby Vision HDR10 Remux. Now this little eye is something new I've just noticed a couple days ago, so I can hover that over, and it has a little bit of extra information where it says HEVC main 10. So I'm going to force this into a transcode. Well, before I do, let's look at the CPU usage. The system is at 7.96%. It raises to 12%. Very minimal. So now we'll force this into a transcode. And I'll do the same 4 megabits per second, 720p. And you see it really transition instantaneous, but it took a second for it to reflect the transcode. HW means hardware. The software transcode is always off the CPU itself, and it is not resource intensive like the transcode would be if it was off the CPU. Off the iGPU, our usage is still low for the CPU. Unfortunately, dashboard does not have a GPU usage. But if you're running a server in Unraid, okay, so I'm not set up to show this test Unraid server in this boot of Ubuntu. I normally use Pop! OS. Let me pause it and make that happen. And I'm back. So now I've got a Chrome app for my second instance of Unraid right here. It opened off screen, which is good, so I can do my password. And what's going on here? Oh, I know. Let me pause this again. Well, no, let me show you what's going on. I use Smart Auto Move, and sometimes when I'm filming or recording, it creates wacky things. So I couldn't move that window. This remembers the positions of program windows under Linux, but it kind of messes up when I'm doing a video recording. All right, so here's this Unraid 63.2, this test server. If I go to the dashboard, I have it set up where you can see what's going on with a GPU. So the GPU is being accessed now for this transcoding. Let me throw this over here and let me resize this dashboard so you can see it's transcoding. Off screen, I'm going to take this out of the transcode and let it direct stream again. Well, that didn't work. Let me rearrange this so it will work. Okay, so you see the GPU isn't doing much right now. Let me put the video back into a transcode. Same 4 megabits per second, 720p. So we see the change reflected here, and now you see the GPU starting to be activated. The 3D rendering load is 92%. Doesn't matter if I have one of these transcoding or 8. This just does it. It doesn't crap out. And at my location, I can only come up with 8 actual decent client devices to test a transcode with it. I've made those videos. I have some short videos showing this GPU and this iGPU. The GPU in this desktop and the iGPU in this system. So this just is amazing. So again, we look CPU usage is still under 20%, even though it says the overall load is higher in Unraid. Unraid's the only place you're going to easily see this. There is a setting under Linux you can run, or a terminal command you can run to get GPU information, but we won't get into that today. So Unraid is pretty cool in that regard. You'll see I just installed Plex Media Server on this system for this video. Okay, so let's take this out of Transcode. And again, it's direct streaming. Nothing really happens to the CPU usage, and we're back to a direct stream. So what's next? Now we're going to do the Walker Ubuntu Snap package, which will use the Nvidia GPU. So let me stop this. Let me change dashboards. And let me find it in the HTPC client app. Okay, so we'll start this up. It's a direct stream, and you're going to notice a difference. Now it's reporting 192 megabits per second versus the 104 for the direct stream. And I can't find a Plex support article that covers this, but I just added this movie to this test server a short time ago. So my theory is that when media is first added to a Plex server, it has the highest bit rate of the media displayed, and after a while Plex must index it somehow to then use the average bit rate, which for this particular movie lists at 104 megabits per second. Now I won't go back because you'll just see it in the next stream I run. It'll show at 104 megabits per second for a direct stream. That's my theory, and I'm sticking with it until somebody proves it otherwise. It just makes sense. All right, so this is off the GPU, so it's not going to affect the processor at all. So let's put this into a forced transcode. Same 4 megabits per second at 720p. Now this is a very powerful GPU, but you notice it's not starting up as fast as the fabulous iGPU and that mobile 11th gen processor. The Tiger Lake Iris Xe iGPU is a fast little iGPU. But we are transcoding, and it looks good. It's the very beginning, so I can show it to you. And we're transcoding to HEVC. Before that new feature came out, this would be an H.264 transcode. So basically, we don't really have to worry about tone mapping going on, because this is, if we click here, it's an HEVC HDR original, and that HDR is being transferred through the conversion, from my understanding. So this really helps a Windows user, because tone mapping wasn't available unless it was on an 11th gen mobile or newer Intel processor. Not available on 11th gen or older desktop processor. So this is working, but just remember, this very expensive Nvidia card, which I use for Handbrake on this desktop system, isn't as quick as starting up a transcode under the 11th gen mobile processor for 11th gen iGPU in an Intel processor. So let's do that again. Switches back to the original stream pretty quickly, and let's put it back into a 4 megabit per second 720p transcode. Not quite as fast as our first test, but you can run a lot of these transcodes just like you can off the other one. So let's stop this, and let me just revisit the other server just to show how fast it is. Okay, the direct stream starts up, and again, see how the average bit rate is now shown instead of the max bit rate? Okay, let's put it into the same transcode right now. That's pretty fast. So people say the Nvidia GPU can be better for whatever reasons. I'm not buying it. Picture looks just as good, and this is a 4K monitor, as it does under either system, Nvidia or the Intel iGPU. All right, so what's next on our list? All right, this is my current Plex server that no longer has hardware acceleration until the hopefully the next beta version of Unraid comes out. So we're going to show you a software transcode. Let me get that set up in the HTPC client app. All right, this is a bigger library, so let me hunt for that movie. I know it's here someplace, right there. All right, so this is further along, and you see it's the same 104 megabits per second as the average bit rate. Direct playing fine. Now we're going to force it into a transcode, and it will be a software transcode. The same 4 megabits per second, 720p. So it's a heck of a processor, the 12th gen i5, I'm sorry, the 14th gen i5 in the Asus NUC. And it started right up, but you see we're missing the HW. And let's play around with this. Let me just check something. Okay, let me, oh, I stopped it. Let me resume it. Starts up pretty quickly. Let me change it to 4K 20 megabits per second. This processor can handle this pretty well. It's quick. It's quicker than the GPU in this desktop, the 3060 Nvidia. But we're using a lot of CPU usage. So without watching dashboard, let me take this on a transcode. And we'll watch the CPU usage fall off in a second or two. There it goes, it drops. So let me put it back in that 4 megabit per second 720p transcode and see if it jumps up to 80% like the 4K transcode to 4K was. It's really not going to matter what level you're transcoding to. So now I'll change it from 4 megabits per second to, instead of 20 megabits per second at 4K, I'll do 10 megabits per second right now. All right, we see a little droppage of the CPU usage to then pick back up. So you can imagine at this much usage, just off the new 14th gen i5 mobile version of an Intel processor, you're not doing many 4K transcodes off the CPU, which is why the hardware acceleration is worth the price of a Plex Pass all by itself. All right, let me take this out of transcode so it's not left in transcode, and we'll watch the CPU usage fall to the floor for the direct stream. Okay, so let's stop this. And let's see what our next system is. So this is my older Synology NAS that doesn't have the HEVC experimental support. So the direct stream starts up really quick. And now we'll force it into a 4 megabits per second 720p transcode. All right, it's not started yet. Now it started on my HTPC client app. So it's not as quick as the more modern systems, but it is handling this transcode just fine. If I look down, the CPU usage is still pretty low. I've tested this iGPU before, it can handle 5 of these same transcodes, the same movie transcoding on other devices before a 6th transcode raises the CPU usage too much and it becomes unstable. So even this old iGPU and this NAS, which also is the same CPU iGPU combo in a Synology DS918, like this DS1019 Plus NAS, it's still a very capable Plex server because you shouldn't be transcoding 4K video anyway. You should be direct streaming, which means to share this type of 4K media. Let me take it out of transcode. You really want gig fiber access, or at least 500 gigabyte both ways fiber access. You're not sharing 4K off from a cable, a coaxial cable ISP. All right, so let me stop this. And we have one more to test. Let's do my newer Synology NAS and the test server on that. Okay, so the same 104 megabits per second, the movie started up. Let's put that into the same 720p transcode. And I'm waiting for the movie to start. Just started. So there is a delay on these older processors and iGPUs, but it handles it with ease. So we see the HW for the hardware transcode. We see the CPU usage is raised, but it's not horrible. Now the Plex Media server is what's going on. I have no idea what else is going on in my Synology NAS right now. I don't think much is going on with it. But this one I've tested. I can do 6 of these same exact movie 4K transcodes before a 7th one makes it unstable. I think it's 6. So this is, even though it's a better iGPU than my older Synology NAS, it's very similar, only this one has the HEVC support where the older one doesn't. So I'll revisit that next. So you see where it says HEVC? Everything's been HEVC except for my current server, which has no hardware acceleration, and my older Synology NAS. So let's take this movie on a transcode and stop the stream. And let's revisit the newer Synology NAS with its 2019 era processor. And I'll show you that HEVC experimental feature again. All right, so the movie started. We'll put it into the same transcode. So it's not playing. Now it's on my screen. You see where it says HEVC. Oh, I've screwed this up. My mistake. Sorry. Let's take it out of transcode. I meant to do this on the older NAS to prove that there's no HEVC. I got sidetracked. So none of my videos are scripted. They're all unscripted. I am not a pro YouTuber. I just try to get information out the best way I can. All right, so let's take this into transcode. Okay, so we see it's transcoding its hardware, but it's transcoding to H.264. So this older iGPU does not have that ability. And you can usually just tell by the name of it. So let's go to the transcoder settings, and it doesn't have UHD in it. So if it's an Intel iGPU and it says UHD, it's probably going to have the new HEVC settings. So let me take this video out of transcoding and stop it. And there's one last thing I want to show you about this new setting. So let me go to my newer Synology NAS. And let me turn off everything. Okay, so if I want to enable hardware acceleration, I click this, Save Changes. Then that pops up this additional option for hardware accelerated video encoding, Save Changes, which now pops up this option to enable HEVC video encoding, Save Changes again, which pops up the final option. So it's important to remember that it's not just one action, it's these multiple ones. I don't know why it's that way, but it just is. Okay, so this could be fun too. Let's click all these off, and this will be our last test. This is an older 9th gen Intel processor. So I want to show you what this NAS, this DS1520 Plus, and the same processor is in the Synology DS224 Plus, 423 Plus, 920 Plus, 720 Plus, and I think the 220 Plus has a different Celeron processor in it. And if there's a 420 Plus also, that may have the same Celeron as the 220 Plus. I'd have to check the NAS compatibility guide, so that's just from memory. So anyway, transcoding, hardware accelerated transcoding is disabled on this NAS right now. So this will be our second example of a software transcode of a high bit rated Dolby Vision HEVC HDR10 4K video. So a potato can direct stream this video, and that's what we're starting up. So we've got 4K Dolby Vision HDR10 with this new little thing to click on, which I guess you don't click, you hover over it. So we had a little bit of a delay with this using the iGPU to transcode. So I'll tell you when I select the transcoding and when the video starts under a software transcode. I've selected it now, and it hasn't started yet. Now it's started. And it's buffered a little bit before it started. Now it's buffering again. It's playing a little bit and it's buffering. Let's bring this back on screen. You see how we're buffering? So even though I have a great connection locally, everything's wired with gig Ethernet cable through a fast switch, this isn't able to handle the software transcoding because it's just too old of a processor. So let me take it out of transcode, and it's already playing. It's playing buffer free because again, a potato can handle all this. So we go to the settings and re-enable things, we'll be all set. I wanted to use this because in one of the Plex articles it talks about passmark score. All of that is just for software transcoding. None of it has to do with hardware accelerated transcoding. I never stopped the video. So let's see, can we do one more before we end the video? All right, so we just did this newer Synology NAS. This is an i9 12th gen processor. We could turn off transcoding on this, or we could turn off transcoding on the, I'm sorry, this is a 12th gen i9, this is an 11th gen i5. Let's turn off the transcoding on this and see how it handles a software transcode, because almost anybody can come up with a system that has a 11th gen Intel processor in it, and this will be the experience if you don't have a Plex Pass. Alright, so it's this one, And we'll disable everything on that. No iGPU for us. So let's go to the right dashboard and let's try this again on this test server. Having multiple test servers to help with videos to help people out is so much fun. All right, let's resume it. It's a direct, nope, it's a transcode, and it started right up. I had left it in a transcode, but look at this awful picture. Look at the pixelation with this software transcode. Hopefully I won't get a YouTube strike. Let's try some other resolutions. This is supposed to be a 4K. Now that looks better, but we've got some buffering, and maybe it was only buffering, but I still see pixelation in that picture. Let's go back to original quality. No pixelation on this 4-screen monitor. So let's put it back into the 4K transcode, or the 4 megabits per second 720p transcode. So it's not a great picture. It's not horrible, but it's not a great picture. Let's look at our software, our CPU. Ladies and gentlemen, we're not getting two 4K transcodes out of this CPU, even though it's an 11th gen processor. I think we should continue the video. I think we should check my 12th gen i9 just to prove a point of even a fast processor like that isn't going to do many of these high-end 4K transcodes. All right, so I've taken this out of transcode. Before I forget, let me put this back to hardware acceleration. We'll enable all the options. So now we'll change to this server, which if I go into the settings and go to system and go about, it's a 12th gen Intel Core i9 12900K processor, and well, we see the iGPU in the settings, so I don't have to dig for that. So it's the RTX 3060 iGPU, and we'll get rid of all of this, which will then cause this test server to transcode off the actual GPU or the CPU itself. All right, so let me find that server. You start that stream up. Again, direct stream. And again, this is 192 because it hasn't been indexed by Plex. In a week or two, it'll read 104. So let's take this. Well, let's look at the CPU. Nothing. Let's force this into a software transcode. 720p, 4 megabits per second. All right, the video started up quickly, but just like the other one, it's pixelated now. It's not the same nice stream we're used to. So you see it's an MJPEG, MJPEG transcode. I haven't seen that before. And this 12th gen i9 processor does better than the 11th gen mobile i5. So maybe you could get two 4K transcodes out of this, maybe more, but see, it's rising now. So, long story short, the Plex Pass is worth the price of admission, and this is a pretty crappy picture, where it's always beautiful. This is a 10 megabit per second. It's still kind of pixelated. This is a 20 megabit per second. It looks less pixelated. But I still think a hardware accelerated transcoded 720p option looks better than the higher resolution transcode under a software transcode. So this is kind of what it is. And so basically this is all just basic information for Cameron. And now we're finally going to get to Eduardo. So you have to have a Plex Pass. You have to be signed in with the account that has the Plex Pass. And you need to go to your settings. And you'll only see your one server. You have to go down to the transcoder section. And you drop down and you click hardware acceleration when available, save the changes, click the next option, hardware accelerated video encoding, and if you want to try this experimental feature, which is working perfectly fine in my opinion, click that, and then click the HEVC optimization. And you don't have to do this. This can be left to auto, but you do want to verify that your GPU or your iGPU is listed here, and I'd suggest just changing to it and saving the changes so you always see it. Now, I haven't set up a temporary transcoding directory here. On my Unraid setups, I specify that setup in the container, and that requires me to add the /tmp, which is how I do it. Some people use dev-shim for like a plain Ubuntu, but that would be RAM transcoding, and that's what's set up in my container. I'm sorry I missed that. In my regular Unraid server and now the test Unraid server, transcoding goes to RAM, and I use a line in the container to make that happen, and then it requires this addition here. So, long story short, that's the basics on hardware accelerated transcoding, and I've shown you how it works under different CPU and GPU options, and we've run a couple tests on the CPU only. So, I'm sorry, different iGPUs and different GPUs and CPU only options. So, thanks for watching and happy plexing. I know this is a long video, but it is what it is.